Okay, now on to the second module, which is equations of motion. So what we're going to do here now is just derive the equations and just tell you what these equations are. And for the problem section, we'll just do the problems in the past paper sections, and you'll learn how to use these equations basically there. So let's just begin. Now, the first derivation is the easiest one, which is u plus at. This is the first equation of motion, and this is a very easy one. So you know the equation a is equal to v2 minus v1 divided by t, right? Now, in these equations, the value v2 will be written as v, and the v1 will be written as u. The initial speed is u, and the final speed is v, right? So just keep that in mind. Now, moving on. A is equal to v minus u over t, and this becomes at is equal to v minus u, and finally v is equal to u plus at. So this is the first equation that we have just derived, right? Now, moving on. The second equation is displacement is equal to initial speed plus final speed divided by 2 multiplied by time. Now, the formula speed is equal to distance over time, or velocity is equal to displacement over time, considers the average speed for the whole journey, right? This is the average speed, right? So for half of the journey, if you are traveling at a speed of 25 and half of the journey you are traveling at the speed of 27, the equation will tell you the answer 26, which is the average speed, right? So the average speed is u plus v divided by 2. This is the average velocity, right? So just plug that in to this equation, and this becomes u plus v divided by 2 is equal to s over t, and then s is equal to u plus v divided by 2 multiplied by t. Now, this equation is not useful in and of itself, right? And this will just be used to derive other equations. So don't worry if this equation seems a little bit useless, because it's just used to derive all the other equations. So let's move on. Now, an important equation now is displacement is equal to ut plus 1 over 2 a t square, right? Where u is the initial speed, t is the times, and a is the acceleration, and s is the displacement. So the derivation is done using two equations, which one of them is s is equal to the one we just derived, v plus u over 2 multiplied by time. And the second equation is v is equal to u plus at, right? V is equal to u plus at. Now what we do here is just use the first equation and plug in the value of v, because this is v and this is v. Just plug in this whole value here. So this becomes s is equal to u plus at, right? This was the value of v. So plus u, another u which was already there, 2 multiplied by t, and this just becomes the equation above, is 2u plus at divided by 2 multiplied by t, right? So this becomes s is equal to 2u divided by 2t, 2ut, right? Plus a t whole square divided by 2, right? Now, the 2 here cancels out. So this becomes ut plus 1 over 2 a t square. So this is the derivation of this equation. Now on to our final equation, which is v square is equal to u square plus 2as, right? So the two equations we're going to be using here is the acceleration equation, just a little bit changed, right? So the acceleration equation is v minus u divided by t, and rearranging this a little bit, and this becomes v minus u divided by a, right? So this is the first equation. And the second equation is s is equal to u plus v divided by 2 multiplied by t. Now, the t value of this is the value of t is this, and just plug it in here and we'll get the equation. So let's do it. U plus v over 2 multiplied by v minus u over 2. So this becomes s is equal to v square minus u square, right, divided by 4 divided by 2a. Sorry, divided by 2a. This is not 2, this is a, divided by 2a. So this just becomes v square is equal to 2as plus u square. So these were the derivations of our equations. And the practice will be done, as I said, in the past papers. And I'll see you in the next module where we'll end the chapter, right? So thanks for watching.